Hi everyone, Mr. Eric Kua here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Alright guys, so today let's go through this synthesis question. Okay, this one is from PJC, paper 2, question 6. Okay, phenacetin, right, was used as an analgesic pain-killing drug, can be synthesized from paracetamol below. So you can see this reaction scheme given to you. State reagent condition for step 1 and step 2. So step 1, right, basically you only neutralize the phenol H+. So basically it is your base. Any base will do, or even a sodium metal. It can be used. All right, so from step 2, you're going to add in this alkyl group. So probably you got to use a halogenal alkane with chlorine or bromine. Either one will do fine. And then just heat it. Okay, so just attach a halogen to it. Okay, for part 2, student added aqueous sulfuric acid to paracetamol and heated it. So if you add sulfuric acid to paracetamol, you are going to cleave the amide linkage. So this part here is going to become ethanoic acid. This part here is going to become protonated phenylamine. Okay, so basically that is just what happens. I think the positive sign would be better put on the end instead. Okay, so that's it for this question from PJ. Moving on to the next question, part E. So this question says that halogenal alkanes, they are widely synthesized by heating halogens with alkenes. Okay. And they say halogenal alkanes can undergo nucleophilic substitution using aqueous sodium hydroxide to form alcohol commercially. Give one reason why iodoalkanes are more reactive towards nucleophilic substitution with aqueous NaOH than the corresponding chloroalkane. So this question, right, they want you to compare between, maybe instead of writing R, right, maybe I should write CI bond versus ClC bond. Okay, so CCl bond versus CI bond, what is the difference? The bond energy, the ease of breaking. Okay, the ease of breaking CI bond compared to CCl bond. Okay, I think living group is not really in our H2 syllabus, so I think the first explanation should be the more appropriate one. Okay, sequence of events starting from compound A dihalogenal compound is shown on the next page. Okay, so you have this reaction scheme. They want you to draw the structures of B, C, and D. So if you hit it particularly with 1 mole of NaOH, right, you are going to get iodine substituted to get compound B, which is basically this compound here. The rest stays the same. Okay, so basically you substituted iodine for OH, which is actually what the previous question was trying to hint to you. It's easier to break CI bond than CCl bond. Okay, then after that, you're going to use excess ammonia in ethanol heat. This reagent and condition is to substitute the CCl bond with NH2 bonds. All right, and then for KMnO4, you know that that is to oxidize. That is to oxidize your OH into a ketone, right? A secondary alcohol into a ketone. Okay, so this thing here is a secondary alcohol. This here is an RX. Okay, so your compound will be your amine, which you substitute your Cl with, and then oxidation oxidation of secondary alcohol. Okay, so that's your B, C, and D. Pretty straightforward question. This question, I believe, was modified from a past year 10-year series question. All right, next up, we have halogens can form many interhalogen compound. One such example is ICl, known as Vichy's reagents. This reagent can react with 1-methyl cyclohexene to form a mixture of compound E and A. Okay, explain why A is the major product. Okay, so to answer this question, right, you need to basically know the basics of electrophilic addition. So basically, this I here gets a delta plus, Cl gets a delta minus. Okay, so your double bond, right, will come out to attack the delta plus, and then you will get an intermediate that looks like this. Okay, you get intermediate that looks like this because the positive sign, right, prefers to be on the more substituted carbon here. Okay, so therefore C will the Ci bond, right, will be formed on the other carbon instead. Okay, so this will be the bond that is formed, and then here is your carbocation ion, and then your Cl minus will then attack this second carbon right here. Okay, forming A as the major product. Okay, so this basis is like Markovnikov, which we have learned before. Right, so we see alkene attacks the iodine because it's more delta positive. Then the major product will have the carbon formed to carbon number 2. So maybe we label this one as carbon 1, this one carbon 2. Okay, this will result in a more stable carbocation ion with on the first carbon. All right, guys, let's continue with this question from PJ, paper 3, question 2. Suggest a simple chemical test to distinguish these two compounds. So if you look at these two compounds, right, they are written in a straight line. Probably this is more difficult to see. Probably it should be better for you to write it out. E, 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 H. So this is the structure here for J, and then K, right? C double bond C. Double bond C with a CH2, C3, and then OH here. So you can see very clearly, right? This here is a tertiary alcohol. This here is a secondary alcohol. Both of them have alkenes, terminal alkenes, so you probably cannot test for alkenes. My advice is do oxidation by dichromate, okay, so that you oxidize the secondary alcohol, but you don't oxidize the tertiary alcohol. Okay, another distinguishing test you can do, right, is that you can see very clearly this side has the special structure for iodoform. So you can use the iodoform test, or you can use dichromate, right, to distinguish them. Okay, so that's for part 1. Part 2, right, here on the top part, you have a primary amide. Once you have a primary amide, you basically just use NaOH equals and heat it. This will cleave, and then you will get a ammonia gas, okay, being evolved. Right, so this is a very standard test you can use. Okay, the third part of this question, we see here there's a special structure which you can get if you apply hot acidified CmO4, and then this part will become ethane dioate, right? Ethane dioate acid, which will then further oxidize to become CO2 plus H2O. Right? So that will give you that effervescence, which turn lime water to a white PPT. Okay, so much of this question is just recognizing that special structure that forms ethane dioic acid. Alright guys, so this is the last PJ question. So we have phenylamine suggests the reagent and condition to convert nitrobenzene to phenylamine. Okay, so this is a very standard question. You use tin concentrated HCl, heat it, and then in order to release this phenylamine, you got to follow it up with your NaOH aqueous at RTP. Right? So very standard recall question. Okay, so part 2, right, is a pattern recognition question. They give you a 2-step reaction. All you need to remember is your phenylamine, right? When you put it through with cold nitrous acid, you will get this intermediate, okay, which we call phenyl diazonium chloride. And then in step 2, right, you react it with H2O, okay, H2O. And then what will you get, right? This H2O, the OH, right, will substitute this whole chunk. Pattern recognition, right? You substitute this whole chunk, and then this whole chunk will actually form N2 and HCl with the remaining H. Okay, then temperature must be above 60 degrees. Okay, so with that, right, we are able to change this phenylamine to a phenol. Okay, so knowing this kind of synthesis, right, they want you to propose a 2-step reaction pathway for conversion of 2-methyl phenylamine. Okay, 2-methyl phenylamine. Okay, so if you start with this, how do you get to this compound here? So this compound, instead of a phenol, right, we now have a OR group, which means that the last part, right, instead of using H2O, we're gonna use CH3, CH2, OH. Alright, so instead of the H being substituted, we will have a OR group, which is the group that we want here, being substituted in. Okay, so the first step is the same as your step 1 here on top, so you just copy and paste. Basically, you can ignore this methyl group. It doesn't really do anything from start to end. Okay, then in order to proceed from here to here, you're gonna add ethanol. Okay, you're gonna add an ethanol as we said earlier, and temperature above 60 degrees. Okay, so that's it. Then you will get your product ready. Okay, this is a pure pattern recognition question.